Welcome to this explainer, where we're diving straight into the fascinating and honestly hypercritical world of network automation risk management. For us network engineers, automation is an absolute game changer, right? It totally transforms operations. But if we aren't careful, it's also a highly efficient way to bring down our entire infrastructure at the speed of light. So today we're going to look at the exact anatomy of an automation disaster, and more importantly, the blueprint for success.
Let's actually start with this really powerful paradox from our source material that perfectly sets the stakes for our organizational survival. It says, automation can make network changes faster, but it can also repeat an error quickly across multiple devices. Basically, a tiny mistake in a single variable can cause a wildly larger service impact than a manual change ever could. Automation scales our intelligence, sure, but man, it scales our mistakes just as fast.
So, to navigate this double-edged sword, here is the roadmap we're going to use. Number 1, the automation paradox. 2, 3 critical automation risks. 3, designing fail-safe human controls. 4, stage deployments and rollbacks. And finally, 5, right-sizing your controls.
All right, kicking things off with Section 1, the automation paradox. Speed versus the scale of disaster. Think about it like this. When you optimize a process, you remove the natural friction that slows you down, right? But sometimes, honestly, that friction was the very thing giving you time to catch a mistake. And that introduces this crucial concept of the blast radius. If you push a flawed configuration to a single router manually, well, your blast radius is just that one router. But if your script pushes that exact same flaw to 500 routers simultaneously, boom, your blast radius is the entire company. Risk management is literally all about containing this blast radius.
Moving right along to Section 2, 3 critical automation risks. Let's uncover those hidden threats.
The very first critical risk hits us right at the starting line, and that's incorrect input data. The thing about automation is that it's incredibly obedient. It will do exactly what you tell it to do, even if what you told it to do was completely wrong. It relies entirely on accurate input data to function properly.
To put that into perspective, a single typo in a VLAN identifier or an IP address can crash a remote site instantly when it's executed at machine speed. Getting a device name wrong, fat-fingering invalid interface details, or feeding it faulty variables, that's how you get widespread outages. Our automation absolutely must validate required fields and literally halt execution the second critical input data is missing. Okay, the second risk happens when our automation basically goes rogue and starts making changes way outside the approved scope. We call this an unintended configuration change. As network engineers, we've all felt that stomach drop, right? You think you're just updating a handful of edge switches, but suddenly you realize your core routing policies are being actively overwritten. No thanks.
And this happens when you rely on broad device filters, or maybe you have a hidden template error that accidentally reconfigures your entire infrastructure instead of just a specific target. If your inventory groups are a mess, your automation is going to target devices it has absolutely no business touching. So we have to clearly define target devices, thoroughly review generated configs before pushing them, and definitely use dry run or check mode wherever we can.
Our third hidden threat is the false confidence you get from insufficient testing. You know the drill. A script works perfectly in your pristine, totally controlled lab environment, but then it fails catastrophically on a different operating system out in the real world. Network environments are rarely uniform. You've got legacy equipment sitting right next to brand new hardware. If you don't test against different supported device types and validate your syntax thoroughly, your automation is basically flying blind in production.
This right here is the stark contrast between a Wild West automation environment and a highly governed state. An unmanaged environment hides field tasks and leans on super risky, broad filters. But a managed environment? It defines the target scope rigidly, halts immediately when it hits critical errors, and actually prevents a script from just repeating duplicate issues over and over.
All right, let's pivot to Section 3, designing fail-safe human controls. This is our blueprint for success. Ironically, the most effective fail-safe for automation is actually the human element. When one single person creates and executes an automation task totally alone, the risk skyrockets. Mandating peer reviews ensures a second set of eyes catches those sneaky logic errors or scope issues before execution. And we're not just talking about a quick rubber stamp here. It's a rigorous deep dive check of the automation logic, the input templates, and those crucial error handling behaviors.
Also,
just relying on reverting code in Git is not going to cut it. This is a massive takeaway. Simply reverting your automation code does not magically revert the changes that were already pushed out to your network devices. A true safety net requires explicit rollback plans. I'm talking about backing up existing configs, storing previous code versions, and clearly defining actual rollback commands before you even think about starting the deployment.
Which brings us to Section 4, Stage Deployments and Rollbacks. This is how we contain that dreaded blast radius.
By following these 6 structured steps, you can literally stop a deployment dead in its tracks, before an unexpected error takes down the whole network. You never go from the lab straight to the global network. No way! You deploy to one single non-critical device first, then a small pilot group. Then you stop and review the monitoring data. Only if everything looks good do you expand to additional device groups. That is how you master the blast radius.
And finally, Section 5, right-sizing your controls, matching your governance to the actual level of risk.
Look, not all automation tasks are created equal. A simple read-only inventory scan doesn't need the same heavy, bureaucratic governance as an automated change to your core routing policies, right? If your engineers have to suffer through a 5-day peer approval process just to run a read-only check, they are 100% going to stop using automation. But if you're modifying security policies, oh yeah, you absolutely demand strict recovery controls, rigorous testing, and peer approval.
So your engineering team really needs to weigh these specific factors to dynamically adjust the level of testing required for every single automated task. Ask yourselves, how many devices are affected here? How critical are these services to the business? How easy is it to actually roll back if things go south? Ultimately, the potential business impact should always dictate the strength of your governance.
So as we wrap up this explainer, I want you to seriously consider the true cost of leaving your network automation unmanaged. Ask yourself this. If your automation deploys a critical error tomorrow at 3 a.m., do you actually have the controls in place to stop it, or will it simply automate your next massive outage? Automation risk can never be completely removed, sure, but through strict input validation, rigorous peer review, and staged deployments, it can absolutely be managed. Thank you so much for joining me, and hey, keep building those fail-safes.